Hi everybody, I mentioned in class today that I did not get through quite everything that I wanted to out of section 7.3, so I'm going to start with a brief review of radians, what we talked about near the end of class, and then I'll expand on that a bit, and this should help you with your homework assignment as well. Let's start with a reminder. A radian is an arc length on the perimeter of the unit circle. Now remember what the unit circle is. The unit circle is the circle centered at the origin with a radius of 1. So if I want another way to measure an angle, let's say 90 degrees, for example. So here's my angle of 90 degrees. I want another way to measure that angle of 90 degrees. I can measure the length of this arc right here. If I want another way to measure, for example, 180 degrees, then I can measure the length of this arc right here. What is that distance if I were to extend it into a straight line? How long is that distance? And so the easiest place to start is by measuring the entire circumference. So what's the distance all the way around the unit circle? Well, we know that circumference of any circle is equal to 2 times pi times radius, or pi times diameter. And so the circumference of this circle, the unit circle, this has a circumference of 2 times pi times 1, or 2 pi. That means that the distance all the way around the perimeter is 2 pi. And so we name this angle right here, 360 degrees, we say equates to 2 pi. So this is a good time for me to mention that you need to pay attention from now on to what mode you're in. If you are working with angles and degree measures, you'll want to be in degree mode on your calculator, and in radian measures, you'll want to be in radian mode. Now that I know the distance all the way around, the circumference is 2 pi, I can easily split that in half, and I can say that 180 degrees equates to 1 pi. Again, we're getting pi because that is the length, this distance, the length of this portion of the circumference. And so from there, we can divide the circle up accordingly. If this is pi, then this would be half of pi, or pi over 2. And if this is 1 pi over 2, then this would be 2 pi over 2, or pi, and we could call this 3 pi over 2. Now, if this is pi over 2, cut that in half, and we've been calling this 45 degrees. That's how far we've opened up, as far as a degree measure goes. But if this is pi over 2, then this is half of pi over 2, and half of pi over 2 is pi over 4. And you can use this symmetry around the unit circle. There's 1 pi over 4, there's 2 pi over 4, there would be 3 pi over 4. There's 4 pi over 4, also known as pi. There would be 5 pi over 4. 6 pi over 4, 7 pi over 4. 8 pi over 4, well, 8 pi over 4 equates to 2 pi. The other key angles that we've been talking about in each quadrant with respect to exact values of cosine and sine are the 30 and the 60 and multiples of those. So my 30 degree angle, well, I like to think of how 30 degrees relates to 180 degrees. 30 is 1/6 of 180, and so if 180 is pi, then this would be 1/6 of pi, or pi over 6. Multiply 30 by 2, we get 60, and this is 2 pi over 6. But we're going to call that pi over 3. We'll reduce. And the pattern continues. Challenge yourself, and you should be able to find these other angle measures that I'm sketching over here. Just a quick note, we could also call this, so since this is negative 30 is one way to name this, okay, negative 30 degrees, we could call this negative pi over 6. Now, if we name a radian or define a radian as an arc length on the perimeter of the unit circle, then it's reasonable that we could ask the question, where is 1 radian, or where does 3 radians fall, or negative 5 radians, etc. Notice for these examples there are no pi's involved. So in this question we're saying that if I'm on the unit circle, and I want to travel a distance of 1, so notice not pi, 1, this length is 1, okay, then what quadrant am I in? Well, the fastest way to go about this is to think about what pi over 2 is. So I'm going to get an approximation for pi over 2. And I'll find that approximation by typing pi over 2 into my calculator, and I get about 1.57. So if 1.57 is here, then we can say that 1 radian would fall in quadrant 1. Here it is. We can say that 2 radians is going to fall somewhere over here. If I wanted to travel a distance of 2, notice again there's not a pi involved. I'm saying 2. You want to travel 2 units along the perimeter of the unit circle. 2 units would fall in quadrant 2. 3 radians. 3 radians would fall just short of pi, and we know pi to be approximately 3.14. So 3 radians would fall in quadrant 3. How about negative 5 radians? Well, negative 5 radians, keep in mind, means that we're going to start by traveling this direction. We're going to go clockwise now because that's a negative angle. Okay? And we know that pi is 3.14, so I'm going to go past that. So more than negative 3.14. The question is, will I go past this? Well, this is going to be negative 3 pi over 2 would be another way to name this. And so if I type in negative 3 pi over 2, I get about negative 4.71, which tells me that negative 5 is going to actually be further over here. And so negative 5 radians falls in quadrant 1. 3 pi over 4 radians. So now notice that there is a pi. We talked about pi's in the previous slide. And so 3 pi over 4, let me change colors here. Here's 1 pi over 4, 45 degrees. 2 pi over 4, that's pi over 2. 3 pi over 4 would cut quadrant 2 in half. And so 3 pi over 4 falls in quadrant 2. Last but not least, again, a negative, and we've got a pi, negative 11 pi over 6. Well, if I wanted to travel negative 11 pi over 6, I would go this distance. I'd start off going clockwise, and I would go over to here, which is the same as negative 330 degrees, and I'd end up in quadrant 1. So, again, the difference here that I want you to understand is 1 radian means that I've traveled a distance of 1, whereas if I've got my pi, 3 pi over 4 radians, that's exact, but you can round 3 pi over 4, get an approximation, and you should be able to identify at this point where 3 pi over 4 falls, where negative 11 pi over 6 falls, where 1, 3, negative 5, where they fall on the perimeter of the unit circle. Okay, next item. Determine the exact value of each. Notice I've now got sine, I've got cosine, I've even got tangent, which we have talked about with respect to right triangles. We're going to talk about it just for a moment here with respect to sine and cosine. So what's the sine of pi over 6? Well, the way that I like to go about this is I'm just going to sketch my unit circle. It's just a good reminder for me. I know pi over 6 is here. It's 30 degrees. And so what's its sine? Well, at this stage, you should be starting to get familiar with that. The sine is the y value, the vertical component, and in this case, we should be thinking that the sine is positive 1/2. You can certainly check. Make sure, you can check using your calculator, make sure that you are in radian mode, though, and not degree mode. What's the cosine of pi over 6? In other words, what's the horizontal component? Well, at that angle, the horizontal component is going to be positive square root of 3 over 2. Again, check. You'll see this about 0.866 pop up, and you need to start getting comfortable with this. When you see that number, recognize it as that. Of course, we're going to be working with exact values largely and not so much approximate. The tangent of pi over 6, well, the tangent is defined as sine over cosine. So if I want to find the tangent of pi over 6, I can take the sine of pi over 6, 1/2, and divide it by the cosine of pi over 6, root 3 over 2. Now dividing by root 3 over 2 is the same as multiplying by its reciprocal. So this is the same as 1/2 times 2 over root 3. Those 2's reduce. We get 1 over root 3, which is certainly acceptable. But we could rationalize the denominator by multiplying by root 3 over root 3, just a fancy way of multiplying by 1, and we could get root 3 over 3. That's an equivalent way to write the same value. This one has a rational denominator. The denominator has been rationalized. This one does not. They're the same. Cosine of 11 pi over 3. So I'm going to continue to challenge you. Maybe pause it right now and see if you can determine it on your own. Okay, so the cosine of 11 pi over 3, well, here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4, 5, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3. And so 11 pi over 3 is more than 2 revolutions, and more than 2 revolutions, so that's more than 1 revolution. That's more than 2 pi is what I'm trying to say. And the question is, what is its cosine? Its cosine should be 1/2. Again, don't forget to check your answers. How about the sine of negative 3 pi over 4? Let me change colors here. So here I am starting at 0. I'm going this direction clockwise because the angle is negative. There's negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. And think about what its sine is. What's its vertical component? Its sine is going to be negative root 2 over 2. Lastly, challenge question, what's the tangent of negative 3 pi over 4? So I'm going to be at the same angle. Well, the nice thing about these fractions with a 4 in the denominator are we know that their sine and their cosine are going to be either plus or minus root 2 over 2. In this case, the sine is negative root 2 over 2, and the cosine is also negative root 2 over 2. When we divide that by itself, we end up with a tangent of positive 1. Okay, next thing that I want to talk about is converting. So converting from one to another. So convert from radians, for example. Convert from radians to degrees. Convert from degrees to radians. If I want to convert from radians to degrees, I'm going to use a conversion, a unit conversion. And that conversion in this case, change colors again, is going to be 180 divided by pi. Now I want you to think about what's happening here. One way to think about this is 180 degrees equates to pi radians, and pi radians equates to 180 degrees. We're just converting from one unit to another. You can think of it almost as multiplying by 1. Now we want to clean this up. If I've got a fraction multiplied by a fraction, then I multiply through in my numerator, I multiply through in my denominator. The pi is reduced to 1. 180 divided by 3 is 60 over 1, and we get 7 times 60. We should be getting 420 degrees. And so 7 pi over 3 equates to 420 degrees. Convert negative 13 pi over 6 to degrees. Again, multiply by 180 divided by pi. Okay, my pi's reduce to 1. 180 over 6 is 3 over 1, and we get negative 39 over 1, or negative 39 degrees. I said negative 39. I meant negative 390, because 180 over 6, of course, is 30 over 1, not 3 over 1. Okay, for the sake of time, I'm going to let you try that one on your own. Let's move on to converting from degrees to radians. So if I want to convert from degrees to radians, then instead of multiplying by 180 over pi, I'm going to flip that fraction. I'm going to multiply by pi over 180. Leave the pi alone. Leave the pi alone, because we're going to end up with, we want a pi in our answer. We want exact values, so leave the pi alone. And reduce 80 over 180. So our zeros reduce, and 8 and 18 are both even, so we can clean that up to say negative 4 pi over 9. Negative 4 pi over 9. Convert 110, positive 110 degrees. So again, we'll multiply by pi over 180. You've probably noticed that if you're converting 2 radians, then you want the pi in your numerator, whereas if you're converting 2 degrees, then you want the pi in your denominator. Again, leave the pi alone. Leave the pi alone. And reduce 110 over 180. Well, 110 over 180 reduces to 11 over 18. There's not much more we can do with that. And so 11 pi over 18 would be our reduced answer there. Again, for the sake of time, I'll let you try that one on your own. Hopefully you get the idea. Converting from radians to degrees, we'll multiply by the conversion factor 180 over pi. Converting from degrees to radians, we'll multiply by pi over 180. Think of it as multiplying by 1. You're just converting from one unit to another. Next item on the agenda. We want to use the equation S is equal to R times theta. Okay, S is equal to R times theta. Well, let me first identify what S stands for. S stands for span. It's a fancy way of saying arc length. So this is our span. That's S. R is our radius. Theta is our angle, but in this case, it must be in radians. So if the angle is not given in radians, if it's given in degrees, then you have to convert first. Notice here it is given in degrees, so we have to convert first. Our goal is to determine this span. What is this length? What is this arc length, this span right here? So we know that the arc length S is equal to R, 4.8, times, and we're gonna round to three numbers. We're gonna round to 3 digits here, okay? Round to 3 decimals here. So S is equal to R 4.8 times theta, but remember that theta is currently in degrees, so 210, and I'm going to multiply that by pi over 180 to convert it to radians. So to solve for span, I'm going to take 210, I'm going to multiply it by pi over 180 to convert to radians. I'll take a moment to type that in. And when I do, I get a span of approximately 17.593 units. In other words, the length of this arc from here to here, that length is about 17.593 units. I know that. I've got a radius of 4.8, and I've opened up an angle measure of 210 degrees. We converted that to radians. We found the span, that arc length. Next example. We're going to add a layer. Now we want to find this ordered pair of P in addition to finding the arc length if the angle is 71 degrees and the radius is 0.7. So let's start by finding the span. Okay? S, and we'll round to 3 places again, span is equal to R, 0.7, times theta. Theta is 71 degrees, but again it must be converted to radians, so times pi over 180. I'll punch that in. And when I punch that in, I'm getting approximately 0.867 units. In other words, this radius is 0.7, this length right here, this span, is about 0.867 units. Okay, so we've solved for S. Again, we're rounding in this case to 3 places. Now for the ordered pair. Well, as we talked about in class earlier today, the X value of an ordered pair, if it's on a circle with perimeter not equal to 1, is just R times the cosine of theta. And the Y value is R times the sine of theta. And so P is equal to 0.4 times the cosine of 71 degrees. Make sure you're in degree mode if you're going to use degrees. And then the Y value is 0.4 times the sine of 71 degrees. Again, I'm going to, for the sake of time, because this video is getting long, I'm going to assume that you could type those values in and round to 3 places. I know you can. Okay, last but not least, let's apply that S is equal to R times theta to a word problem. So how far does the minute hand of a clock travel in 2 hours and, that should say, 19 minutes if the minute hand is 10 inches long? So as I often do in class, I'm going to draw a picture. I've got this watch, and a watch has an hour hand. I'm sorry, a minute hand and an hour hand. The hour hand is shorter. So this is my minute hand, and my minute hand is 10 inches. There's a symbol for inches. The question is, how far does the tip, this should say, the tip of the minute hand, so here's the tip, okay, how far does it travel in 2 hours and 19 minutes? And of course we're going clockwise, so it's going this way, okay, that direction. How far, what is the distance traveled, in other words, around the perimeter of that dot right there? So if you think about it, this dot it's 10 inches away, so that radius is 10. And in 2 hours, in 1 hour, it's going to go all the way around the circumference, the perimeter of the circle once. And then it'll go all the way around a second time. There's 2 hours. And then it's going to go another 19 minutes. So let me change colors so you see the extra 19 minutes. It'll go another 19 minutes. Okay? So that's meant to represent 19 minutes. So I've got 2 circumferences plus an additional 19 minutes is one way to think about it. So my distance traveled is going to be equal to that. Another way to think about it is distance traveled is equal to, and this is the more efficient way, is equal to 139 over 60 times whatever my circumference is. The reason I'm using 139 over 60 is here's 60 sixtieths, or 1 circumference, another 60 sixtieths, so that's 120 sixtieths, and then I go another 19 sixtieths to make 139. That's where that 139 comes from. So 139 over 60 times whatever my circumference is. Now we can find the circumference, as we talked about earlier in this presentation. Circumference is equal to 2 times pi times r. It always will be for any circle. And so distance, total distance traveled, is 139 over 60 times 2 times pi times 10. And at this point, we are 99% of the way there. I just need to type that in. And when we punch that in, we get approximately 145.560. And we'll round that, or round that to 3 places, and we'll give it a unit, inches. And so this tip of the minute hand, in traveling for 1 hour, and then a second hour, and then an additional 19 minutes, traveled approximately 145.560 inches. That's all I've got.